Alright, we're going to enjoy some Kellogg's protein cereal today. Whole milk. Never anything other than whole milk. It's a bit of a thing, right? So, I was watching Driving for Answers, right? And he just put out a video about this unique engine. And of course, the idea is, if you watch me, I had a similar idea in the past. But I want to go over why I personally didn't want to go with it. Just because, well, people might not understand why it seems like it might not be the best idea. And he probably goes over that. I haven't quite finished the video. Obviously, I sometimes get distracted. I haven't eaten a whole bunch of stuff. So, that's the thing. Anyways, I was like, alright. So, the basic premise is there's different loads, just like he talks about for balancing on those gears. It's great to have a ring gear, but when the other gears, well, yes, they're smaller, they're also fatter and technically more expensive to make, while on top of it being heavier than just a camshaft. Like, it's a belt, right? And a smaller, thinner gear that's bigger. That's it. It's a lot less expensive, just straight up to make. Then gear grease, of course, or any other lubricating oil that they would try and use, of course, has to get into that gear. And that hydrostatic pressure is what's going to need to be required to effectively not have it ever load in. You don't want it to, like, lock the gear into the tooth, into the other tooth. Like, it just likes to break things. So, like, it always has to be slightly offset, just to kind of, except it can never really quite do that. Right? And now, this will mean not much to most people, right? But, like, for what it's worth, if it's going to cost more, because you have to also rotate a cylinder. It's air cooled, okay? But it's like you have to rotate the cylinder. It's wonderful as a concept. I love it. For what it's worth. That's why I thought about it in the past. You know what I mean? Because, like, oh, who hasn't thought about it? Like, just rotate the cylinder, you know, around with like a fucking hole at the top, right? If you've ever really thought about like internal combustion engines, making your own stuff like that. But it's like little holes at the top. It's like that's what supports that cylinder. It has to have a bearing there, right? It has to do that. No matter how good you get that gap, like, you know, like this is one of the other parts of that problem. It's kind of like, you know, the cylinder valve, which I love, but I ended up going away from it because it was easier to try and seal something else than use that as a thing I could use to seal. I mean, after a while, I was like, well, you don't really need. You almost don't even need the actual cylinder. Like, I know it sounds stupid to some. It's like, why? It's just a tube, you know, whatever. But it's like, if you make channels in it, and then you're already going to cut off this side, and then it has to, it just almost makes sense to just make it two tubes, and after a point, it's like, why would you rotate it that way? You could just rotate it together with the thing, like they're doing half, and that's just a gear, you know, with an axle that goes up to the top, which is inevitably what I ended up thinking about for this two-plate system that would rotate and have like a film of oil and on the outside, and then it'd basically be trapped in between the cylinder. And anyways, point is, that meant it had a stationary, and effectively it was very, very well sealed as a result. It's very hard for it to break. However, I then eventually went even further and went towards like cylinders themselves as, you know, like, hey, well, two-strokes exist. If I'm going to do a multi, like, you know, small, you know, cylinder band ring thing for like a valve, then why don't I just get a bearing journal separating the two, you know, make sure that it's slightly differently in terms of thickness here, so that way it balances itself and it's able to always have a nice film, and that constantly keeps it sealed. right? And then just kind of carve it the right. I talked about it otherwise. But point is, the cylinder itself rotating, great way to work around a certain problem, except, of course, you can't really get around that, soot problem. You can't, like, it's going to build up eventually. Like it has to have a gap that it can't have, right? Which it's going to try and fill up anything during that pressure. So it always loses a certain amount, right? And that's kind of rough. I love the idea, by the way. It's such a nice way to do it. It seems so simple, but it's just a little bit more complicated as a result of how to make it work. Which is why I ended up not going with it. A lot of my other designs don't use anything like that. I do use gears sometimes, but they're actually offset crankshaft types that use these cool crescent types in my designs with an elbow pin. So as I have an elbow pin, and it's like, this is all rigid for a reason, because it's a better way to effectively get around that problem, and it can have a much more extreme offset. And anyways, doesn't really matter. I'm still working on some of that, so But I wanted to talk about it because it was like, it's a really awesome way to think about, and it works, obviously, right? It's like, it's working. Hey, it works. So it's cool, right? But it just has certain caveats to it. Like those wide, like when it goes down, and he's talking about that counter rotating. Well, that also puts a stress on those gears, right? As it's rotating, it causes a torsion event in the double crank. Double crank and connecting rod, for what it's worth, right? So what that does is it causes flex, torsion. So it can never be very high torque. It can never be very high RPM, which for the most part, most people won't usually care. And they're right about it being super compact and lightweight, right? But it's like, no, but like, like, to put it in perspective for me, I feel like that could technically be the same thing if you were to do it slightly differently for a single cylinder of the same size. But, it does depend pretty heavily here, because there's many ways of designing an engine with many materials, and so I feel like that's getting into semantical weeds. The material design. So I don't feel like that's really what I want to focus on, because I love that part about it. It's super compact, and that's really nice. It acts like its own flywheel, which is great. Like, it's effectively a differential with a cylinder on the other side. You know what I mean? I know that sounds kind of weird, but it effectively is that. Yeah, it's a different. It goes in and has a groove, and that's what actually spins it on the other side. You put a nice seal on one side. You get a diaphragm. It's an air, pump at that point. Effectively, you can use the very thing moving backwards and forward to literally create a change in volume and help pump more air into it. Not that I'd probably like that, I suppose, after a point, because like we're talking about tolerances, of course, but we're also talking about like outright amounts of pressure within inside of a cylinder, right? But I do know that it's still really cool, and it does produce a decent amount of power, like it has to, but it's not like a given, but it is what it is. I do like the idea and concept, and it can work. Ostensibly, obviously it is, right? But I was thinking about it, and I'm like, well, how much loss is there in those big gears, right? Like, how much actual loss is there? And I go like, well, because it's in a cylinder that's rotating, that means they have to cover that with something, or there's a gap. Which, if there's a gap, that means where that area is for the valves has to have something connected to it to help act as a bearing, and same thing with the cylinder side, because you don't want it to travel around. In fact, you probably for sure gap the shit and tolerance the shit out of where that circle is where it exists. You know what I mean? Like, I can guarantee you the dude did it, right? But like, it's not gonna work forever, and they know that. Like, they'll have to eventually take this off just to put in another. Which I was looking at those white rings, and I'm like, is that a PTFE? You know what I mean? Like, is that like one of those higher temperature, kind of things where like you put the right, oil there because it needs a bearing anyways, and that helps thermally transfer, right? Because it's air cooled, but it's like it's gonna help thermally transfer, right? Like a bearing, yeah, like an oil, like a journal bearing, that kind of thing. But like, I haven't gotten that far into it, obviously, but still, it's just gonna. There's only so many ways to solve this. Is the point I'm trying to really get across? And I go like, well, there's longer term endurance problems for sure. With how that's set up, right? And depending on the materials here, it'll last for a really long time. It'll be just as good as anything else, for what it's worth. So there's that. But I'm like, okay, so if you wanted to do this and you knew it was rotating, all these things were rotating. It's like, well, you should have gotten some magnets and some coils for the rings, the ring gears, and the other bearing gears, I guess, and put it on the shroud or engine block. I mean, it's a cylinder that's really there, but then like there's a. So I'm not sure how they're going to define that, but like it's an engine block, right? But it's the air cooler, but it's more of a shroud to the cylinder kind of thing. Anyways, if it was there, then that would give it a degree of that, extra efficiency, which would be great, actually. Right? So you should do it for what it's worth. That and like effectively making a slightly more like sealed rotating part to that valve that's a part of that movement of oil, right? Because you're going to need it in there anyways. So it's like if you're going to need it in there, then it's like instead of that being like this, it'll just rotate together with that, right? And then like that's a pump because it's rotating, right? So like that creates its own pump as a result, and that helps cooling and heating. Piezoelectrics can suddenly get involved, right? And that's electricity. And hey, ring gear and some of that's what? An electric motor. Right? Pretty, annoyingly, right, simple, but like it'll help efficiency. More than anything. If you're gonna make it, and it might be ultimately more expensive to make and manufacture because that's what it's all about for them. Then it's like, well, then claim to fame, you're going to pay for higher efficiencies. That's what you're going to do. You know what I mean? Like, that's the easiest way. Like, I already have a pump here that's already there inside of this little, the hollow and then the axle, whatever. And then, like, that allows for that to go towards, right? And so, like, intakes, and then it, goes off, you go through a little cooler or whatever, fucking, right? And that's an air pump, right? To pump it in. Now it's a little bit more sealed where the valve is. Great, right? It's got a little bit more balance in terms of it can't rock if anything were to happen and goes too high of an RPM, right? Because like there's enough pressure there, oil-wise, to basically force it to kind of stay as an oil-bearing journal kind of thing, right? You get the right grooves and the tolerances, and then you're able to allow for it to rotate really well. And now you also gain a little bit of increased efficiency for all of the extra cost that it takes. You gain massive efficiency, right? Buffs, effectively. And that's a good thing. You're going to want that. But you also maintain a higher performance average than most, right? All at the same time as having the whole thing act like its own bearing, which is in flywheel. Right, which is a good thing. Objectively, it's a good thing, right? But it's like that's a lot more. How much more? And like you want magnets, you need coils and the thing, and I'm like, well, yeah, but it's worth it. You know what I mean? Like at that point, like you could get possibly 70% efficiency. That's not nothing. Like, if you could get 70% efficiency, because that's turning heat into work energy back into the system, that's not nothing, right? But the reason why I'm talking about it for the little air pump thing that I was talking about, right? That seals up a system of differential pressure, which helps hydrostatic pressure. Okay? That's a hard part of that. Like, it reduces torsion too, and blow by. Like, blow by has a harder time getting through. That torsion, which isn't much to some, but the higher the RPM, the worse that gets. Like, harmonic imbalances are not what we're talking about. We're talking about tertiary imbalances. And in fact, this would be quad imbalance, truthfully, or whatever that is, because that's literally a spinning thing that's then going up and down. That creates a twisting, compressive, and also elongation, tension force as a stress that slowly eats away at things. At first, it's not a big deal, right? But it's like over enough time, it'll become something you have to worry about, which is material. And at that point, you'll throw out the engine because you have to replace connecting rods, a wrist pin, possibly the gears too. And if the cylinder gets, roughed up as a result, the cylinder as well. Which is kind of rough to deal with. Right? Like, at that point, it's like, fuck, I just need a new engine. You know what I mean? Like, I don't want to get a new engine. It's a lot of work. Granted, it's like, and plop it in. Right? It's not a hard, thing to just buy it and then put it. But it's like, that's the problem, as for like a single cylinder system like this. Like if you're talking about like a multi-cylinder system like this, like say a V8 somehow you wanted to stick this together, which by the way is theoretically possible. Then it's like you're talking about a whole V8 that has to be replaced. Like, that sucks hard. That would suck so much. You just wouldn't want to do it. You know what I mean? So, I think it's a great idea. It has like some flaws, and some of those flaws are kind of the same flaws of the other engine that was unique that he covered. When it came down to, like, it's effectively a bump stop, but it's a camshaft, like a camshaft lobe. Sits in a ring, it goes up and it goes back down, that kind of thing. It's a 2-stroke scavenge, but they call it a 1-stroke. But the only way, to put it really simply, if they had just had like another power stroke on the back side of that, right? Like, that would have made it so it was a technicality wise, even if it is a double 2-stroke scavenge, which is all 1-stroke practically, except for hypergolic or, material that. Anyways, point is, right? You like injectors, you just inject it in, and then you use a spark for the injector. It's basically a rocket injector, effectively. Turbine jet engine, little miniature thing. But move on from that. Because I've already talked about it on my YouTube channel. If you want to look at that, go ahead. But like otherwise, it's not really what I'm here to talk about. It's like, well, that's kind of the same problem that they're suffering from right now, right? Like, it's like, okay, it goes up and goes down, and they're having the same degree of those little problematic details that can cause those issues for them in the long run. Like, they're also compact, sure, but like, all they had to do was literally make a double 2-stroke scavenge on the other side that would have yanked it forward, right? But it's like, that would have been a bad thing. You see what I mean? Like, it only gets power from a downward stroke. And lo and behold, they can't possibly put a secondary ring on the other side to effectively get a yank stroke back to workable work energy here. Let alone have it spin like a radial, right? Where it effectively sucks in air from the center, because it's a hollow 2-ring structure. Imagine it's there, right? And then like that sucks it in, and it blows it out, right? It would be super simple. Like, now it's a whole flywheel, right? Like a whole it's its own like rotating flywheel along with pump thing that's a super turbo kind of thing. All you have to do is have it like effectively catch that on the exhaust, right? And then it starts rotating itself faster. That's all it has to do. But like, of course, it costs more to manufacture. Like, and we all know that. But like, it's worth it in that sense of efficiency. And if you already are new on the market, you have to provide something that makes it so that way people would go, okay, for this application, for this going on, for this amount of time, for this cost, it's worth it. Which ostensibly right now, I would say, which is not the right word, I hate that word for this, I'd say for the majority of people, objectively, they wouldn't see a good reason to do it. And they need a good reason. Like if I had a motorcycle engine, like a little single cylinder scooter, let's say it was that. That's that kind of like CC. I'm pointing behind me because it's on the screen. But like, I think it was 125 cc. All right, that's a good scooter. But it's like, imagine if it was 70% efficient. It's like, let's say it made like 10, horsepower at the, it's 30% efficient. Okay, right? And once it gets really hot and all this other blah, 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 it gets to 70% efficiency because that's how a heat engine works, standard stuff. It's like, well, you just added in 40%. There's 10. So that's 4 more horsepower, right? That's 14 horsepower. 14 horsepower is no slouch for 125 cc. In fact, that's what a motorcycle engine is, really, realistically, and I don't need it to be nearly as heavy anymore. The problem is, of course, I might end up having to replace my whole engine. So that would suck a little, especially if it was like, $1,000, $1,500, something like that, or less, $500 or hell, even $100 would probably still suck. If I can get it for 50, big old smackaroos, 50. I might, hey. Now, granted, we're just contributing to waste at this point, is what it feels like, yeah. So, but, in terms of market, I know for a fact that would work. People would pay $50 for an engine like that in every way. Hell, even 150, they'd probably, especially if it lasted long enough. We're talking like, oh, they got 10,000, 20,000, whatever miles. 150, all day. I'll fucking replace it at 150. You know what I mean? So, then do it. I don't know how much it really costs to make. I don't really know how much real power it makes, and I don't really know how realistically speaking, long it's going to last for right now. But a few little touches to making sure that it lasts a lot longer will help it a lot. Especially that little air pump, which is wonderful because that's its own type of heat exchanger in a way. You know what I mean? Although I don't know how much people might know that, but like if the shroud, right, that's not the heat exchanger, right? It's like as that heat, it still soaks into the oil. We're talking about the oil heat radiator, right? But it's like, okay, so it's gonna, and then it's gonna exchange it anyways. So wouldn't it be nice? And it's a 1-to-1, except not technicality wise. This is about volume and shape. So it's like if it has this volume, it tries to take in and it accelerates at this amount, and then it happens to go to this kind of size, and then from this side it then gets expanded, and then technicality wise it condensed, which that's a air to air intercooler, so like whatever. But right, then it's like, okay, then it went from there, and then it changed from this volume, which was always like the same amount of air molecules, but whatever. It then got denser, but not really. It remained the same total amount, but it's more concentrated in one area. Which, why isn't that compression? But, far be it from me to add in the caveat, it needs heat for compression, or it doesn't need heat for you to be able to do. So then all fucking cooling is just compression, just in a reverse manner for heat. But whatever. You know what I mean? Although I've explained that and used that in many aspects on my channel, because it's like, that is literally what that is. No offense, but it is. Just FYI. Like, even fermionic to baryonic. It's like, well, I cooled it and got it really, moving the vibrationally, wave functioning right way, man. And it got more dense. Turned into 1 instead of 2. It's like, okay, whatever. Still, you're compressing something, but, whatever. So, moving on. But, like, I like it, but he needs to be able to, like, make effectively the gears mean something better than what they currently do. Right? Like, the way it's currently set up, it doesn't seem as possibly as good of an idea right now. Like, it's just gear shaping. It's like making sure that it has that, like, proper, bracing, I guess, against the side of the engine block, right? So that way it can slide. That's an oil bearing, effectively, journal. So that way it effectively can't get moved against anything. It can't torsion itself, right? And, same thing for the connecting rods. Like, the connecting rods, if they have just even a slight little, thing that's sitting in between that makes sure that it just can't rotate and twist that way, which is effectively like a strut almost. It's not. It's a linear, supportive bearing strut, whatever you want to call it, but that's literally what that would be, right? But that helps it just remove all possibility of it doing that, right? Which is a good thing. That, with the shape of the gears now being a little bit more round and that ring gear being a little bit more band gear, kind of like how they have in transmissions, then that means it rests up against that a little bit more, and that allows for it to effectively brace itself against that in its own right, which helps tremendously reduce outright load on any one part, especially if it was joined in on the side, but as effectively almost like a diagonal gear. They call them conical, but I was like, they look like a trapezoid when you look at them flat, but okay. It looks like that. I'm just saying, it's not quite the right call, for what it's worth, the conical, but it's a type of, I don't know what they're called. They're not worm, but I don't, they're similar to that sense, right? Like almost like a hollow conical, right? But, like, that means you now have a bracing that allows for you to sit in between, and that would help, right? Spread load, because it's now more like a triangle. And now you don't need one little, big, well-machined, ring gear. You can have, like, actually speaking, a little easier to find and source gearing that's already made, So, hopefully less tolerance as well, because now you have 2, and you don't have to worry about it having those issues as much, or needing to brace against anything as much, right? Which is a good thing, but then the other side of me turned into kind of a bit of a dick, because I was like, okay, real quick, just preferencing this, it doesn't work, so hold on before you think, oh my god, well, no, it doesn't, hold on. But what would it take to basically run 2 things off to the side and then have the cylinder rotate off of, like, a different cylinder that's, have these effectively bearings that go into grooves on an outside cylinder, with this being a part of the more 2-strokey, if you wanted it to be that way, but not if you don't, side of things for a regular piston, because it goes through and it rotates, and then that just rotates against gears, grooves on the outside of it for the cylinder. Again, it sounds so much like it's going to work, but it's the same bump stop problem. Okay, it's literally the same bump stop problem, for like the other engine, You know, if you had it on the one, sucks, right? It's like, well, how would you fucking what? Sounds like it'd be great. There are shear forces. I saw some dude do it for his bike, you know, for pedaling. As it goes down, he gets more torque throughout the entire pedal stroke. Well, yes, but also kind of no. And here's the thing. For a person pedaling, there's not a lot of shear force. Right? But this is the equivalent of, and it pounds in and it has a lot of torque and it wants to fucking, and if you ever think about that, it's like it's trying to crush this part and then it goes up, right? And, and tries to compress it. And we already have camshaft lobes, right? So it's like we know all about like pounds per square inch, all that. It can survive. And it's a little bit more complicated, okay? Like, it is. It has this spread out. It has this massive amount of heat. It has to be constantly cooled. It also does more than just compress it over time. Like, have you ever heard of hardened steel? I'm sure someone out there has. But, like, that's a thing. If you keep pounding hardened steel over enough time, even if it is not even that hot objectively, right? It becomes work hardened. And it's like, it's even harder steel? There's what? Right? And it's like, that's not good, for one thing. It also deforms and reshapes. Right? It might not be something that we really care that much about, right? But what it means really realistically for all of us is that it doesn't survive for very long. The bearing, the roller bearing, which is what that would probably end up having to be, you know, it's got to be one of those kinds of things where it's like a whole bearing that has to have, you know, a lot of oils constantly supplied to it. Well, as it goes into the groove, it has to make sure it can rotate. So that's like a different type of, you know, wrist movement, but you know, that's kind of more the forearm. Anyways, but that's more like a ball joint, basically. Right? And so anybody that's ever known anything about any of these wheels that have like these little swivels, you know, you notice that they don't really survive much, right? They don't seem to like to live for very long, right? And there's a reason why. Because there's a lot of concentration of weight and stress in one small spot. So it's like you have to turn it into a hemisphere where it kind of cups itself like a ball joint. And then like this has to properly swivel, kind of like how you write like in a big pen, right? So like, and that has to allow for oil to get all up in there and make sure it's all lubricated properly. And then it has to still allow for it to fit within the groove, all while transferring its load, which you can't do to the outer. No, you thought that was going to be the case. No, that has to be perfectly somehow not moving, even though it's suffering massive movement, torsional fucking loads. So it's like, and I'm trying to go down and it's moving. All because it's, well, probably a better way to get it to rotate. For what's for it, that's all it is. It's the equivalent of the crankshaft, but in the whole thing. So as it goes through, it's sort of like a helical or double helical threaded, you know, bolt. Basically, you can spin the nut up and down, and it can still tighten, right? However, it comes with mass, and I told you already, it doesn't work. Okay, so right off the bat, it's not a real thing. However, you can make it work for a little while, but everything gets destroyed. Tolerances on those things gets worse. You're told to change your bolts for a reason. It suffers material strength and stress and fatigue far faster. It wears out much more quickly. Everything effectively wears out way faster. And by the way, if this is connected to that, it's like this single cylinder has to be connected to another cylinder at the top that's sealed to the thing. It can't go around that, right? So like you have to have a cylinder too, and that has to go through, right? So like that has to be attached. So this has to either go through that one, or it's sitting within a whole bunch of things. Not super complicated because there's only a couple of ways to do it. Think telescoping pole, right? Like how stuff made here that is just telescoping, go gadget. I'm gonna dunk on you now, boots, right? Versus this one, which would be a little bit more closely to a hollow tube within a hollow tube that then has a full-on hollow tube, more like hydraulic ram with an outer shell for the hydraulic ram operation. Which is like could be done, absolutely. However, it now has to spin, and that's your whole torque. This thing spinning, which it spins one way, you want it to keep spinning. You never want it to stop spinning. Like you don't want it to, and then it started going back up the same way. No, in every way that would destroy the thing. Too many loads. The faster it spins, the worse it gets. Everything. So like if it's spinning, you want it to continue spinning to maintain momentum, because that's both its flywheel right there, because that gets it back up after it goes back down. Like it's a constant thing. But of course it has to be cooled, okay, right, already. So that means it's bathed in never-ending amounts, well, not really, but like of oil or hydraulic fluid, something there that happens to help transfer heat, right? Has to be there, right? It's got to have a seal, which is why I ended up going with injectors for my, like, you know, initial. This is like everything could just be injectors at that point, like for what it's worth, right? And then you just have like a solid center, and it goes down, and then that presses it out, and then you know, both sides effectively are combustion zones, right? What that means, however, is like that's that hollow cylinder, right? Like that's in the center, that's your exhaust. However, because there's still depth in that, you know, and there's an inside diameter and an outside diameter, and there's still a tube in between. That's where my injectors can be. And oh, wouldn't you know, shocker, I have to put my injectors near my exhaust, along with wait, my spark plug. Wait a second, that doesn't sound quite the same as I once really believed at first. So then I switched it over to like, maybe I can make it like hollow for the other tube, you know, that instead of like the exhaust, it's actually the tube that moves up and down. And it's like, well, that space has to go somewhere, obviously, right? So instead it's like, well, that's probably not that worth it. So instead it's like more like a pot design that goes into another tube at this point, right? Screw it. I can just stick these to there, and then it'll spin, and then I'll go back up. You know, and then I only need this length, right, for cylinder. Standard stuff. That fills up volume up to the top, and as it goes up, it fills up volume of oil at the bottom. Standard stuff. Right? But that is also a hydraulic fluid. And that's a pump. Hey, that's a pump. I can use that. I can, you know, that's a thing I can use. But here's the problem. Like I was trying to get across, it doesn't actually work. There has to be a way to get the damn cylinder to go back up. The hydraulic pump, by the way, can do that. That's hydraulic ram, right? So it goes down, it's pressing, of course. It's also rotating, right? That can be attached to something that allows for you to get that rotation, right? Of course, as the pump goes down, you know, that moves the fluid back up to the top. But in so doing, of course, that helps effectively get you some more torque kind of thing, right? Because that's like a torque converter, effectively. So that's a good thing, but it's also, I use Stirling engine design. I'm like, well, if there's you know, that's a metal sponge if I do that right, because like I need these little spindle fucking things, you know, some heat exchange. I can do it. There's nothing saying I can't do it, especially if it changes its phase. Like objectively, I could do it. Right? It's like, why does it sound like it would work? Why, you know, I kept trying to make it work. That's the thing. I kept trying to make it work. I'm a bit of a dick, right? Like I kept trying to make it work. Why won't it work? Why the fuck? It sounds like it'll work. What the hell is the problem? Why won't it work? Right? It sounds like it's gonna work. It's like it's got bracing on the bottom and the sides. It's rotating. That's a good thing. I want that. It's doing the thing. There's a way and a pattern to do it. Why won't it work? Why can't it work? What's the problem? Hell, the little torque axle thing, that can be hollow. That's my fuel injector or spark right there. Easy, all day. I can even effectively attach that so that way, even though it is rotating, it's like a brushed motor, effectively. It has a contact. It's, I can do it. I can do it. It's not that bad, right? I can get it from the sides of the cylinder, like a 2-stroke for the intake, right? It's like nothing here says it can't. Why can't it work? Shockingly, it's the same reason as always. Wouldn't you know it? I said it in the beginning. It suffers from a bunch of failure points constantly. It needs never-ending, constant maintenance and tolerance, perfection practically. It literally doesn't work just because of that. It is the worst thing. It's like, no, it sounds like it'd be so good. But everything about it effectively wants to cause expansion, contraction, rotation, which, by the way, the bane, as it rotates faster, it's expanding more. And it's getting longer and then shorter and longer and shorter and hotter, and it's cooling and all. It's wanting to always break its tolerance. It's wanting to always screw up its material. It's not ever seeming to stay together, right? So it turned into a big, massive, splendidly, tons of little things pointing to the side of the cylinders, little thing at the bottom, all of it. It's like, wow, this is way more complicated. I just fucking ruined the whole thing. This is way more complicated than that guy. It wouldn't work. This is the stupidest thing I've ever done. Like, what the fuck is this? The hell is this? Makes no sense to do. Just doesn't work. But theoretically speaking, it could work, right? It's like, theoretical is great until you get into the nitty-gritty. It's like, all right, let's get into the nitty-gritty about this engine, right? The driving for answers is talking about. And I'm like, there are some problems for sure, right? And it'll eventually make it so that way a whole engine has to be ripped apart and put back together, or just straight up replaced, which kind of sucks. There are some ways of getting around it, but of course it's immediately more complicated. It's going to cost a lot more. This, what it is. For the amount of weight savings you get, because you got rid of a gear and then those tiny little crankshafts and the head and all this other stuff. Well, it starts adding up, and the complexity has to go somewhere. Relatively speaking, those are fairly simple. It's a spring, a pop-up valve, and so on, right? But all of a sudden, it's a little less simple. It's the complexity gets put back into the system at the bottom end, right? So it's a bit rough. It's just what it is, And the only real way to get around it is by adding a little bit more strength in the right places and slightly changing the design and effectively, giving it a good marketing push. It's now going to be far more efficient because, of course, I'd use it if it was that efficient, right? Like, absolutely, I'm going to use it. Like, I've got basically an electric motor engine hybrid together. Why wouldn't I? I mean, it's got a supercharger. It's an air pump that's running off the crank, and it makes boost. You know what I mean? Like, it's gonna make hey, right? Because that's a certain size of diaphragm to a smaller size. It takes it in from this volume, it goes to this volume. It accelerated it, but hey, that's boost. That's boost. And you can tailor your boost by simply moving something around, like a little valve that just opens up enough and takes in a little less air and makes a little less boost. That's fine. Okay. But it works that way because, well, it's enough efficient. That's if 70%, of course, obviously, right? But, like, I mean, come on. Is it worth it? Yeah, I think so. I mean, we need new engines. Internal combustion engines are everywhere. You know what I mean? We can make, for what it's worth, with the materials we actually do have, like, on hand, on tap. Like, we have thermoelectric and photovoltaic, thermal photovoltaic, but we also have piezoelectric. Like, it makes no sense that we don't use those, except for the fact that, of course, we need strength in certain places, and it's like, well, yeah, but you're not realizing you mix those. Like, and they actually handle that heat and pressure pretty well once you add the right materials together. Now, I can't cast that. It's like, yeah, no, but like I've described a couple of times in my videos, you can grow it kind of like you grow crystals, but also kind of like how you electroplate, but also kind of both for what it's worth. You know what I mean? It's like a mold. Effectively, the stuff's in a solution, you let it fall, you put it all together. Essentially, you track them together, and then you compress it a little bit, and you heat it up a little bit, and you finish it. That kind of thing. It uses a lot less energy now. And, it's been used before, but it's not a super high technique. It's like, man, I electroplate my engines. I'd electroplate my engines. I'd download a car. Are you kidding me? If I could download a car and 3D print one, I would. Are you for real? I would absolutely do that. Are you? I would 100% do it right now. Don't even try. You would probably too if you're watching this video. You would absolutely download a car. Are you kidding me? So, like, to be fair, I get it. But also, it's not quite like there, obviously. And they're trying to just get this done with what they already have. I get that. Okay. So, no shade, no nothing. I think there's a few little things that they have to do to basically make it work a lot longer, and in such a way that they don't have to replace things anymore, which is wonderful. Like a whole entire engine, at least until essentially you'd want to anyways because of wear rate or something else. Standard actual wear rates, right? Like a gear does eventually wear down, right? Like a wrist pin does eventually wear. All of that happens. So it puts it back into, it lasts as long as everyone else. And is the weight much more or even the same? Well, no, it's not. That's the thing. Like the rotating, like all of it, it already weighs less. So they're not adding more weight, right? They're adding more complexity, which is the part that, we all kind of know, and depending here on what we're talking about, it will be more weight. Right now, they're sitting in a sweet spot where it isn't. The moment they want to add more, they'll weigh more than other types of designs out there, which is a big deal. And it just takes a little bit of change to the design currently that they have. Just a little bit of strengthening. That's it. And then it would work just as long. At least from what I initially saw, I'm only like a little past the halfway point of Driving for Answers video. Okay. So, and then my mind just like, well, if ultra simplicity, just cylinder within a cylinder, inside of a cylinder, if it moves and it does the thing, and like it's basically the same, right? Except it's still, you want to make it more simplistic, right? But you can't. And it's like, well, you can get rid of injectors. You just run a carb. And it's like, right, yeah, I know. Two-stroke it then at that point, right? It's like, what transfers it? What makes it not effectively? Because, like, that rod's attached to it, that goes somewhere. You know what I mean? That, sure, it's rotating, but it goes in and out, in and out, in and out, It's a thing. That has to somehow transfer to something, right? Somehow it has to do this. Somehow. And it's not currently doing that. Right. Which, that sucks. That's the part. It's like, no, it seems like it works so well. It just doesn't work right now. There's a way. I eventually figured out a way to do it for what it's worth. but like that turned into another extra tube. It's like there's the engine block tube, and then there's the statically, but it's not that statically tube, but that's the one that actually rotates the tube. That's a part of the other thing that's rotating tube that actually has the compression in all the rest tube that then goes to the exhaust tube. I've got 4 tubes instead of 3 tubes. Get on my level of tubes. Noobs. You need more tubes for your tubes, because yo dog, I heard you like 2 tubes and tubes. Meta here on the YouTubes, you know what I mean? So, but, anyways, I like the design though. I do. I don't like using gears more often than not, because unless they're very offset, because they're in line in the way that rotates, it causes an obvious fault to both torsion, tension, stress, strain, and compression. Basic kind of problems that all gears kind of face, but you tend to not want them to face it. Like the times when they do face that, we're talking they're usually very small and they don't have a lot that goes through them, right? So, not every time, don't get me wrong, okay, and it will last, it's clearly a thing. But, watches are intricate with all of these things because they're small. And they don't have a lot they have to worry about. A person accelerating and braking. A person suddenly turning. Right? This also, gaining more RPM while doing so, all of these different factors will more quickly wear it down. No, not completely, and it only takes a little bit. That's all I'm trying to get across. Okay? It's definitely a good design. I just didn't want to do it myself because, I personally prefer it off to the side. I don't like it in line. That's all it is. Like a cylinder that's just there, and then this offset for gearing, that's right there for the crank. You have a little crescent, it goes up, it goes over. So it's like as it goes down, it goes up and over. Right, and it goes back up, and then this locks up, and then this can go up. Right, so that goes down, that kind of thing. Right, then I get a little girdle right there, nice little, this moves, and it's always pretty much, very structurally strengthened. But it's a nice little pivoter bearing kind of thing. Now it's a pump, right? I can now make the thing hollow because it's perfectly up and down. This is the elbow pin that I can use to help pump regular oil into the cylinder. The cylinder is now closed-ish. It's semi-open. It goes to the piston oil ring, right? Oil ring always gets oil. That feeds all the rest of them. Great. But the majority just uses that to effectively cool the piston, right? And lubricate everything else. And I only need to make sure that during the bottom it pulls a vacuum in the crank and the head for what it's worth, and then I fill the rest of it up with any excess blow-off that I don't want, basically. And that's just a basic valve, and that goes off to any exhaust area that you want. Alright? Pretty simple stuff. That's why I ended up getting those cylinder kind of styles of, rotating bearing journal valves. Because if they rotate around, then it's like, oh yeah, no, it's perfect. Then it's closed. It's good enough. And then the exhaust, this is the big shocker. I turned my piston head into a valve. With that little opening, that little closed thing, that's hydraulic fluid, like a ram, that then can move a little ring. That ring then opens, pops up the head. It's able to go and flow through, and of course there are connection points. I do know that. Okay, but that means because there's a little ring there, it situates itself over, and it's like a pop-up valve, reverse style. So when it's pressing it, it makes it so no gas escapes through. Exhaust goes to the bottom. As it goes back up, of course that fills up the bottom. I don't need anything other than injectors at the top. The cylinder is now far less complicated. I don't have headers. One single cylinder is all it takes. All I use is some big meaty air injectors. This is a little cylinder, sure, but it's not really a cylinder that's that little, right? We're talking about, hey, this is an intake valve, right? And then a one-way check valve, basically, that goes to the equivalent, because that's our intake manifold, for the injector of a fuel rail, right? But I don't want nitrogen, so I usually nitrogen filter, because it's easier. So I pour in fuel, that, of course, dumps heat into the fuel. I draw a little bit of a vacuum, and that's mostly what I want, until I get near enough to the bottom, and then that allows me to dump a little bit of that oxygen-rich air, because I'm filtering out most of the nitrogen, like a very high percentage. And then that allows for it to effectively soak a little bit of that heat into it, but it won't cause combustion. It's too lean to even burn anything effectively. Not really, because it could, but it's just not hot enough to really do it, and not compress any of that stuff. So, anyways, it goes back to compression. It's still basically the equivalent of it didn't really compress anything, but it's enough now to burn a little. I'm trying to inject just a little bit before it gets to top dead center. Kind of like the reverse of a compression ignition engine, a diesel, which is great. However, because it gets to there and it burns, it's like, okay, that's great. But now I have an oxygen injector that can match that pressure, and I can continuously burn it with the excess fuel that is, of course, there. Like retarded timing on the spark plug, right? So it burns very close to near bottom dead center to be able to get any kind of power, but it's a turbo anti-lag effectively, right? Except in this instance, no, I'm burning constantly as it goes down, right? It's the very definition of, that's fucking awesome. I'm gonna suck in a little bit more of that burning fuel, because there's still rich fuel there, right? And that breaks it apart and turns it very elemental, man. Right. Anyways, it just means it burns more cleanly, basically. But it's a duct, kind of what it seems like. However, it's the equivalent of what we've seen on engineering explained in many other videos, I'm sure, if anyone had ever talked about it. But it goes up a little tube, it goes into a spark plug, it's now highly concentrated, more enough oxygen and fuel, it burns, it goes down the tube, it then spreads out like Formula 1 boom boom spread spray thing, basically. Except in this instance it's more of a Bernoulli, I don't know. Point is, it's sucking in fuel and burning it because it's hot enough, it's going through a Bernoulli's principle version, and it compresses it in a little nozzle, burns that. But, far be it from me, because the nozzle would eventually melt, and I'm not looking for the nozzle to melt. So, what that really means is that it's not really quite that kind of thing. It's built into the very cylinder itself to do this, and so it allows for it to actually get cooled by coolant. It's just like any other Nesibiland, you know what I mean? So it's cooled. It's good to go. But it's fine, because I don't really want it to do much more than effectively just mix it really well with the Venturi effect by using Bernoulli principles. As it goes down, creates force, there's a lower pressure up here, that creates a continuous flow, which continues making this happen. Which is a good thing. That means I can have a very high flow rate, and in fact, it doesn't see the same kind of pressure you think it would see. Which means it actually is fine with regular even methane. I just have to get a quartz tip. These things burn hot. So I don't wanna. You know what I mean? They burn pretty hot. So I do have to get a bit of a liner there for it to work, and that's fine. But that's the point, where it's okay, so it's burning really hot. That's actually really good. That's highly efficient, right? It creates a lot of pressure, but it's already fairly high pressure. We're looking to get close to that 1,000 to 1,500 psi at top dead center. Right, but it's fuel rich. We're talking loaded. because that's actually the safest way to do this. I'm not gonna lie, like it's actually the safest way. Like to run extra lean with oxygen means it will try and oxidize everything, which is bad. You can't do that. So it's like you have to run super fuel rich, and it's like I'm always trying to hit stoichiometric mix, right? Because like that's the most efficient way to do it. So I run super fuel rich, but it's like this is at this RPM means this piston speed, which means this amount of time to be able to accelerate, because I can't really keep accelerating it once it gets to middle dead center. It has to decelerate. So it's like, how the fuck do I get rid of that? I hate that shit. That shit sucks. That's gotta go. How the hell do I get rid of it, right? So it's like, and oh, what if I fucking curved this and made an elbow pen and it was straight up and down? And then it only went up like this, basically, and basically, right? And it's like, it pauses effectively, so it goes down, goes up, there's a little curve, goes back down, it gets to the closest, lowest torque value, closest to the center of the axle, right? And then it goes back down, and rapidly, it locks up at that point, and it's trying to, so it takes a little bit of time, right? That's perfect, because that means, you guessed it, the valve opens. I can change that ever so slightly with a little bit of a solenoid, a little bit of action, right? And now I got variable valve timing, variable valve duration, variable valve lift. All of that. So, great stuff. That then flows into the bottom. It's sealed, because I want it to be. I don't want it to just rush out. That's not good. That's extra pressure I could use. I don't need as big of a flywheel. That's basically what it's about. I don't have any need anymore for complex valving. You know what I mean? I have one, it's like a push rod valve, but it's like a hydraulic fluid push rod. It's a hydraulic ram, you know what I mean? Like we've had these things. These are really simple stuff. So anyways, neither here nor there, but it goes through, nice, simple, quick, goes up, closes. I can then push a little bit more fuel up there, standard stuff, starts cooling it immediately, right? It's already oil cooled, effectively, the piston. So like that's good, and it's going to be cooled on the outside, right? Because that's the cylinder. You don't want it to have that problem. But the reason why is because like my first idea and thought was, oh, the gear would be really easy to use because I can change it based upon a cone. So like that would go through, right? And then that would allow for me to change cone-wise this little area of where it connects, right? And so I can alter the crankshaft and alter, ultimately speaking, because power stroke wise, right, I get the most torque I can get off of doing that. That's what I'm doing off of that. That little yank closest and then furthest. Like it goes up and then it yanks it closest and then it goes from that center and down, right? That's a huge amount of torque. So like all the way, right, it's the most amount of torque I can really get. But if I alter the gears just a little bit, right, I gain even more torque. I change the gearing ratio dynamically. Perfect. That's why I use gears in that. But I don't technically need to use gears. I can use just a regular CVT that's a plate system, basically. It's conical, right? But it's like, if I use conical gears and whatever, you can use both, basically. You can use either one. That's what I did it for. I get far, like a Venerator, yeah, but like far more torque as a result. But I also get far more control over each cylinder that I use this for. And they can be connected so, strong, it has a lot of strength, that it's the same as any other crank. It lasts just as long. It's just as efficient. In fact, it's actually more efficient. Because now it's perfectly circular, right? It doesn't have weight problems of imbalance. And the little downward, offset, right? It's like, well, that's hydraulic fluid. It has an upward, to make the valve happen. Right? That kind of thing. So a lot of that is actually balanced completely out. It's fully balanced out, which is good. But because it's fully straight, right, to where all the power is going through for the axle, I can use that as a different type of hollow, and if I needed it, inertial dampener, any of that kind of like extra balancing stuff, I use it kind of more or less like a pump, because like that pump means I can move effectively a lot of different fluids around that I need for this. So I'm gonna move on. I've talked about it a little bit, but on my channel a few times before. This is, long-winded already. So, but long and the short of it is that it's just something I happen to like to do because it just lasts really long and is super cheap and super robust, very cheap to manufacture, will work for a really long time, hyper efficient, right? And as it goes back up, it's like I'm getting all that torque back, right? Like it has to go back, but it's like I can do the reverse, which means I get that same torque back, which is maximizing torque and energy gain. Well, I can't really get the energy gain, right? Because it's just it's not an actual. I mean, if there's a vacuum, sure, so it's going to try and push it up, yeah, but it's really just reducing flywheel. Okay, that's what that is. So if I minimize that total amount necessary to get it back up, because it's that much easier, I don't need a flywheel really as much as most other people do, which is great. That reduces weight. It reduces complexity. I only need one exhaust valve at the bottom. I only have a bottomer. There's no header. It's a bottomer. It reversed it. You know what I mean? Which is great. That's easy to do. The little bearing journal, we've had these forever. In fact, we split bearing journals all the time. So for what it's worth, all doable. And even like how I put it together, it's kind of like a top hat that has like these little branches out, that then sticks into like little grooves, and because there's pressure and oil there, it then makes it very difficult, and it seals itself. So it makes it very difficult for any kind of gas to get in between. So that's great. You don't want anything other than that. It just also means I got further and deeper into the woods for turbines, super turbos, piezo, thermal photovoltaic, thermoelectric, right? All of the things. I've made it all as a solenoid and now has a catalytic converter, that's actually, shocker, it's a fuel cell-like thing that's using electron redox flow to separate and then make more electrons do more work effectively for what it's worth, because it's already hot anyways. So might as well use that, right? So it's like, all right, so that's solenoid energy. That's all this. That's like, and same thing with those little plates or whatever. But it's like, hey, if I have this and then that, and then that's like a torque converter to like, every single air pulse effectively. So that gives me my turbine that effectively also has like the little straight through axle, which of course has a compressor. Right, so all of that super compact now is made a super turbo out of the whole thing. Right, now has the intake right there, right, it's got all the exhaust, right, you rotate it. I ended up doing like a different thing. It's like my bladeless turbine that's an undulating thing that's effectively a bunch of them, and it moves fluid around, okay, but also I know NASA uses vibrations to, it's an oscillator vibrator torque wrench is what they're talking, about, and like they call it something else, but that's what that is. So I'm gonna move on, and that's it. You know what I mean? Like that moves both the crank, but also that can help move and heat exchange, along with the right little, hey, guess what? I need a heat exchange for the air around the engine, right? And I can still have that still go through the radiator and have a little bit of extra air from around the engine and a little bit more from behind. So it's like all of that, and then I capture with that a little bit further down, Bernoulli's principle. That's hot, it's diffused, it mixes a little bit to the second radiator behind it. Then it finally goes into the exhaust. Basic check valves in the area, make sure, right? But what does that mean? I capture all of the heat energy possible with some piezoelectrics and some heat exchanging into the fluid. Right? That's what that is. And I mean, this is clean air versus the, it got a little hotter and then the exhaust. I mostly got most of the exhaust heat into that fluid, and all of that did work energy into the crank and into the compressor. Good stuff. Well, the engine block, of course, is made of materials that are like that, but then, of course, it still has a vapor chamber, phase, whatever, heatsink thing. They don't call them heatsink fins. I'm like, it's air-cooled, though, but they are heatsink fins. But anyways, make them a little hollow, because you have to make them hollow anyways, to attach to the actual sleeve, the cylinder sleeve thing. So it's like, all right, well, if I do that a better way, effectively, so I have to have fluid there. So if I do this to where I have another fluid on the other side, and then that'll effectively help exchange heat. But that's the piezoelectric, all that stuff. But then I still have like that ability to move, because that's exhaust moving, and also using thermal siphon pressure differentials to go into the waste heat generator, which the waste heat generator is, of course, both piezoelectrics, yes, but it's a little bit different because it uses the Joule-Thomson. So it starts small, gets to medium, gets to large. And then it has another vacuum area that it can expand into, kind of like a reservoir for regular heat pumps, except that's the radiator. The radiator is that, right? It's like, that's the extra. So like, it then wants to cool even harder. And because it's mixing a little bit of air from around the engine, right, I get a little bit more back, effectively, in terms of efficiency. Now, the caveat here is, of course, that's where the crankshaft is, and you get the transmission and all that stuff, and the rest of it is, of course, what that is. Super compact, altogether weighs less than most for what it's worth, and it makes way higher amounts of actual efficiency occur. Which, that's why I talk about it as being like a 99.999%. And of course, this is all the amount that you need to do that. Instead of just thermal photovoltaics, there are actual photovoltaics in this. You have to do the right layer, you have to do the right diffusal, you have to have all the right little connection points for all those little things. And that's why I talked about it like that, with how it was that I wanted to try and manufacture it, right? Which makes less energy now, in terms of like needing to make it. So like, it takes less, it takes less to make the thing. It takes less energy to make the thing, which is good. And the resources are smaller, which means that's a good thing usually, right? We're talking, a lot less total amounts of loss. It makes it more efficient to manufacture it. It uses less energy, it's a less complicated thing, and I don't need to buy as much. Altogether, cheaper. You know what I mean? And hey, by the way, it now absorbs more work energy. Again, all the 90, it gets much bigger once you get to that. The pumping losses are gone because they actually make energy. Now, because like that's the fluid that goes through, but it's not just the valve, because like that's the valve that like actually makes energy as a result of heat. So like, that's its own version of like a pump. Anyways, moving on, because like that pump then gets added into the whole work energy volume. All of it gets worked into making work energy volume happen. So there isn't a pumping loss. There's frictional losses. So I ended up getting into polycrystalline diamond, polystructural diamond, lots of really hard, very slick materials, very specifically, that would last for a very long period of time and under lots of heat and pressure, that are very cheap to actually make when you don't want to make them the same way as the very expensive guys do, mostly because you don't need them to be that level of what that is. So they'll still last a really long time, they're still incredibly hard, all that stuff. And they're great at thermal transfer. Good stuff. Generally speaking, you'd kind of want that, right? But we're talking about his engine, not mine. Right? As a concept, I haven't made. You know what I mean? Like, man, you should work. I wish I could get someone to help. But hey, that's the silliest part about my engine, actually. So the compressor is both hollow, along with the shroud around it, that actually happens to be using that heat, and exchanging and all that to help make it more efficient, condense it on the way as it's compressing, which is good. However, while it's doing that, it's also making it change. It has variable nozzle geometry and vane and all that stuff, which also helps with balancing for what's worth, and all the pumping stuff. So it doesn't feel like it's always vibrating, that kind of thing. But cool stuff. Gotta get off of it. It just means that it makes a little bit more power, makes a little bit more, not just efficiency, but I actually try and turn that heat and then the exchange and mechanical stress and strain into electricity, of course, and vibration that, of course, gets put back in. Right, so it's like, I'm trying to get it as close to 100% efficient as possible. So there's very little pumping losses, and eventually as it spins fast enough, with that little undulation, that's a resonance thing. So like as it goes towards that, it goes in, it's very hot, and then expands and diffuse, has a different flow thing. It comes back around to that whole thing. But what that means is for the exhaust, it then becomes more and more vacuum-like the longer it runs. Different heat and more Bernoulli principle suck force effectively, which turns more and more vacuum-like. So, I know, suck force the vacuum. Here now. But that makes it more efficient. And like the ring, remember the bearing? That's piezoelectrics. That's some contact. That's some heat and pressure. And wouldn't you know it? With a little bit of coil in the right way, and a little bit of, I don't know, is that a magnet? Hey, wouldn't you know it? It's already rotating off of a gear, practically speaking, anyways. Because it has to have that a little bit. But remember that plunge thing I was talking about? That's a bearing and it's a little pump. But it's like, that's basically moving up, kind of like the bump stop, except it rotates it just the right way. And so that causes it to spin in lockstep, the right way. Right, of course, depending on how I play with that, with a nice little mechanical is set up to do optimal air and, efficiency stuff, I can change that to make it even more optimal depending on the situation. Right, but that's a solenoid kind of thing. It doesn't take a lot of energy to do that, right? And of course, that's balanced off of both the pressure and the heat and electricity generated, which will automatically do that. But just in case you want, that level of extra fine, and by the way, absolutely, why wouldn't you? That's an ECU stuff. So, but shouldn't really be a problem if there were EMPs around or something like that. You know what I mean? So, moving off of it, long and the short was I just made it because I was like really wanting the ability to make a very high efficiency. I wanted to stick it to people with electric motors. I'm not kidding. Like, that's kind of where it came from. They were getting all uppity. You can't make an internal combustion engine become 99% efficient. Watch me. I'll do the impossible right the fuck now, and boom. It'll be even just as complex as you basically are, with the amount of little controllers and all these other freaking stupid cables and more. Screw that. I'm as good as you now, especially since I don't really add in the electrical, energy from that battery, right? So the fuel pump, especially when the pump itself for the engine kind of helps with that a little, for what it's worth, because that's a part of the heat exchanger for the fuel, you know what I mean? So like that in the intake and then whole thing. But I'm gonna move on again. Yeah, it's like that's gonna get into nitty gritty things about how people measure work energy, right? And it's like it's getting me work energy as a result of electricity. And because there's heat energy within the atmosphere, and then I'm getting that back as it flows around, and then technically also I don't count the extra from the result of air, just from the air going around the engine and then through and all that. So like all heat is trying to be transferred into actual work energy, which you can do as best as possible. There's always loss. 99% means I have to get real finicky with how I make electrical potential energy work for me, which I just put a video out recently about how to do that. Specifically because I wanted to make a real engine like this to stick it to people with electric motors. and be like, I'm actually better for the environment. I didn't have to burn a fuck ton of coal and then lose it all that fuck, what is that, 15%, 20%, and then I lost it getting it into the battery and all the rest. Nuh-uh, I'm not gonna do that. I'm gonna be cool. I'm gonna fucking make my own ethanol over there by shitting in a fucking, pot, throwing in some other, what is that, a stick over there? Fuck this. Yeah, grind up, here's some freaking enzymes, all this fucking, like a little whole thing. That's the one pot method. That's also on my YouTube. After a while, you know what I mean? And it's like, well, some sun, some wind, that's electrical resistive, and it's just like, right? Next thing you know, I got some hydrocarbons. Hey, why not? Screw it. Like, it can burn almost anything. Like, for what it's worth, just throw it in there. Screw filters, except, like, actually don't do that. Definitely filter. But, like, yeah, you don't have to. If you wanted to condense it, too, for, like, the natural gas or any of that, and throw it in there wet, by the way, as a liquid, like, talk about efficiency, right? Jeez. But then that usually turns into, well, that's the injector at the bottom, which, of course, changes it just to scotch. That's usually always just nitrogen, the pure, because as it goes up, I'm drawing a vacuum. It's like, yeah, through the crank, it's very low amounts of actual blow-by that'll come from that for what's worth for the exhaust, because the exhaust comes out ahead of time, right, before it gets to top dead and the valve closes, basically. So it'll close, and I'll draw anything that's extra up at that, and it scavenges it through, and of course it's still continuing to try, it's more pressure, right? But like, right, it's closed up at the top. So, but, oh, by the way, and it's going back down, and now the exhaust goes back out, right? So the exhaust is taken care of, and I shove in some nitrogen, and it goes out. But it's like, all right, but like, now I'm going to draw a little bit of a vacuum, just to make sure any of that is taken care of in the crank and anything else. And then I fill the rest of it up with nitrogen, because, like, that's a good idea, right? It's like, hey, well, how much pressure can I get in there? More pressure, actually, at this point, is a good thing. So, shove all the pressure I can get into it, and it goes up to the top, right? Does its combustion thing. This is now open at the bottom. And then that allows for me to literally just push it as normal as a power pulse to my turbine. And hey, by the way, I just absorbed all that heat into the nitrogen, which is a good thing. And oh, by the way, also that helps cool the exhaust manifold and everything else. And it keeps it running and spinning more efficiently. I don't have waste anymore, which is a good thing. You want that. So that means one of the worst parts about engines has become one of the best parts. Heat is the best part. I actually use heat constantly. I want it to technically be hotter because of the thermal photovoltaic, although I'm using regular, photovoltaic, but then, there have to be the right materials. And then that's diffusion with constructive interference to the right photovoltaics and all of this other stuff. Moving on. Like, I have to deep dive into that. This is not that video. Okay? So we're not doing that. But what that means is, like, it's more than strong enough. It captures a lot more of that light energy and vibrational and heat energy as the piezoelectrics, and the cooling, okay, all of it is as close to 99% efficient as could be. But even the bearing journals on the damn thing, even the rotating and all that, that's piezoelectrics. Those are in there. Like, I'm not kidding. Like, I went hard on this. So, like, you remember those bearing journals for the wristband or whatever? That's piezoelectrics. That's in there. There's little contact pins everywhere. They're all up in there, man. Like, this is the hardest substance I could make. I got the polystructural, polycrystalline diamonds, the piezoelectrics in there. Getting all the things, anything I can get in there. I mean, the actual piston rings, piezoelectrics in the piston rings. You get it? Like, I'm not kidding. I went as hard as I could. Because, hey, remember the sleeve? I have to get coils in there if I want to make a solenoid. You know what I mean? Like, just because I have a sleeve, that has, like, some of that other stuff. I have to put that there. You know what I mean? Same thing in the piston head. I still have to have either repulsive or a static repulse. Because I say electron redox flow, that's like a Z pinch as I make a current to a given repulse. So it's like that attracts to this repulse, and so like I use Z pinch attractive, that's current high amps, right? It's flowed through versus a high amount of volts that go through a given coil. That's how I ended up doing that, because I was like, I fucking hate magnets after a while. Magnets kind of suck. They always die. As much as I cool them, they always go bad, right? And like it's usually almost always when something else is going bad anyway. So screw it, you know. They seem like overly expensive, and they're for what it's worth for me, right? So it was like, well, I'm oil cooling it, so let's just make a Z pinch. You know, let's just do this. Make electrical potential, and that creates like multiple points, and then it collapses into making the field repulse, and then that's another, you know, and that's my new version of a solenoid. You know, same thing for the little plates, you know, kind of thing, you know, with the right, same thing with electric motor. So, same thing with the torque converter, which happens to have to transfer it, but like that's, you know, heat exchange along with, you know, exhaust going through, along with, you know, the undulation technology, which is a bladeless turbine, but it's not undulate. I get that there's a name. I don't care about the name though, because all it is a diaphragm that goes burr the right way. But if you do it the right way, because that's the exhaust recycling, but except it goes back into the exhaust coming in. Of course, that creates more Bernoulli's, whole thing, vacuum, blah, blah. Already talked about it. Long and short of it is, it's close. In fact, I'm like dead certain I'm at 99% and a little bit more once it's up to temp. Right? But it doesn't really matter that much, because by the time I get to that point, and if it's moving at all, it basically has its own version of a suck, you know, of Bernoulli's principle, right? And I don't really usually need a fan. So like that extra air that comes into the rear, you know, radiator, right? Even though it's getting mixed, it's diffused so much, it doesn't matter that much, to such a degree that it moving alone and it trying to change, right? It's diffusing. Anyways, point is, it cools it fully, completely off, finally, right? And I get everything out of it. But because there's heat energy in the air, because there's heat energy around it, this is moving faster, that's technically denser. This has more humidity, that doesn't have as much humidity. This has technically more pressure, that doesn't have more. I turn it into a big resonant speaker, effectively, that makes it sound really cool, like a throaty roar rocket engine thing. Right? It's like I already need an exhaust manifold and all the, you know, tube and a muffler and blah, blah, blah. Or I can make it sound way cooler, and I get way more efficiency, and it weighs about the same. So I'm going to do that, right? Especially when it's like, oh, transmission is now protected by exhaust underneath. That'll help. You know what I mean? Hey! I love that shit. That shit makes me happy. It's like, that gets me up in the morning sometimes, honestly. Like, stimulating myself about thinking about concepts like, how can I make it even more efficient? How can I make it even more simple? Like, this is the simplest one I've ever come up with yet. It is literally, I could just make it. I can practically print this fucker in a nice mold that I freaking put in the right solution, and, you know, over enough period of time, I've got it. It takes about the same amount of time as before, for what it's worth. You know, granted that's, you know, solution, but it still happens to work out pretty quickly. If you have to wait that amount of time for it to cool, you have to wait it's the same amount of time, it uses less energy. That's good. It's wonderful. It's now super efficient. Uses up less resource. It's actually cheaper to do it this way. It sounds better. It's more powerful. I need less. It actually weighs less than a standard typical, let's say they were 125cc. Like, honestly, I'd weigh less than that guy. But to be fair, I'm also getting away a little bit with murder when I say that. Because, like, you know, I have an intake manifold that I'm also counting on that. You know, like, that's the thing. And then I have the exhaust, which is not really fully like I got to the other radiator, whatever, sure, but and then I'm gonna weigh more. That's just usually what happens with efficiency, but that's kind of what that is, and you always have to deal with it. So usually, we're talking about law of cube. So when we're talking about like certain types and models of car, of course I weigh less, right? But of course, if we're talking about like on like a regular street, motorcycle, I would weigh less depending heavily on the type. Yeah. So that kind of thing. And then, well, it lasts a lot longer than generally speaking, believe most people would want it to probably last. Yeah, like, hey, I kind of maybe want a new car eventually. And I was like, yeah, but why would you? Everything works great. You only need this one. This is it. You only need this. Nobody's really probably going to buy that. They were like the super glass, right? This is the little off topic here. The western side of Germany, the social side, they got this super cool glass. They tried to market it to the glass makers instead of the people that actually use the thing. And it lasts forever, basically, right? Nobody wanted to buy it. I wonder why. We make it because, the money, because, hey, you buy our shit. Do you get it? I kind of need you to do that. Meanwhile, like, they'll have accidents, blah, blah, blah. It's so efficient, I can put it in my... I'm sure it'll be fine, for what it's worth. Maybe not them, though. But, yeah. Right. The air filter. Right, so the air filter that's coming in, okay, this has to be a different type. That's the part of the intake that compresses, right? So it's like I make it more efficient, first off, by making it a ram air to begin with that has a teardrop style, variable geometry intake, all that stuff, right? But what it does is it causes the right vortexes that then takes, really hot stuff and brings it away. And then we get the cold stuff that goes in and it's still going to heat up. But then, of course, I'm trying to, exchange it on the way in and exchange it on the way out and then have the very thing that's compressing it as the heat exchangers, right? Those kinds of things. During that, there's a lot of piezoelectrics, a lot of all that stuff. It makes electricity, continues to make it spin, really super vacuumy, all the other cool stuff. And presto changeo somehow, even though it's really physics. So, good old magic people. Sometimes. But, alright, cool stuff. Then, it's like, right, what that does is it acts like it's pre-air filtration. It's a pre-air filter. Like, this is a big, fat, just make sure nothing big particle stuff comes in, right? That stuff, right? Because that's what I'm looking for. This goes through, it gets all the small little bits and all that, that are a little bit, because it's spinning, it's like a centrifugal for air, right? Then it goes through its own spread and diffuse. So it goes through, it now has to exchange, kind of like a heat exchanger, except while it's doing that, it's making even faster vortexes that are, of course, changing out that heat in one side, and, of course, that's a lot of the particulates that get captured, but then it exchanges while they capture that heat, and then it gets colder while the cold moves through. Right? Cool stuff. Well, it did that. Guess what happened? More electricity. Standard stuff. More vibrations. Cool things. Right? Get it? Because, I'm trying to make it colder. Anyways. But it also accelerated quite quickly. Now it's a very significant condenser, basically. Which is great. Now I have this high flow, and they make these already, nitrogen filter. Okay, I found a couple online, and they can really easily float, like very high pressures too, a lot of nitrogen and air through them, more than enough to run practically any sized engine within like actually decent size. Like even 6-liter V8s can run with this. So like it will be just fine. However, if you don't feel it will, just add a second, right? Like that's how, like literally, like 2 will run everything. 2. I don't even need 2 because like, you know, it's 1 enough. You know, but it's basically the same size of my engine right now that I'm currently thinking about, right? Because it's about the same size as theirs. It's about 250cc right now. So it's like, it's almost the same damn size. So it's like, oh, it has this little, you know, and it goes through it, and there's the oxygen, there's a check valve, and like there's the nitrogen, and you know, it's 2 separate, right, tanks for that. And I have to cool, right, the filter. Good stuff, right? You know, because you need to do that. Can't just be super hot. It has a certain operating temperature room, you know, room temperature or whatever in pressure that it can run at, right? But it's filtered more than enough. Okay. No worries. Right, got the check valve, got the little rail that'll be your air, you know, rail tank thingy, right? You know, for your air injector. The nitrogen, of course, it's going to dump itself into both the cylinder below, but also just straight into the exhaust because it's easier. And if it can't do any, like if it still is producing so much, it will then just dump into the, you know, behind the exhaust to the radiator area, like for what it's worth. You know, like whatever, like even if it's the engine itself around it, like if it has to dump it into that, it'll dump it into that kind of thing. And that's more than good enough vast majority of the time, unless we're talking massive engines, and in which case then, you know, another slight redesign and that's it, typically. But that means I never have a blow-off valve. And I know that sounds so not like, what the hell did I just say? It's like, it wouldn't be necessary. The rotation of the compressor is directly tied to the crank. And it's basically a vibrational thing. So like, it effectively is only ever going to spin at the right RPM forever, and to make the right power. It just gets less parasitic loss to do it. So that means the rest of it's dumped into somewhere else, right? And so that means crank. The crank needs to spin faster, which means this has eventually, if you want it to, a reducing gear, if you needed it to. Although like it's rarely ever a thing for what it's worth. My dog's just trying to get me to play with them with this bone, but it's what it is. But yeah, no, it's this thing where it's like, okay, so it's very close to that level of percentage, like just off of theoretics, okay, just off of that, right? Which a piston engine has never done before. Okay, and it's really robust. Like that little movement, you know, for the piston head, it's within line, right? And yeah, while it's there, it's very minimal amounts that are necessary to have immense amounts of flow. Okay, it basically never has anything that's going to get stuck from heat because it's always getting cooled, but also that air that goes through, there isn't particulate matter. You know what I mean? Like the carbon's burning. Yeah, like it gets hot enough, but also it's vaporizing into the hot top below and then getting expanded below as the exhaust goes away. Right? Like all the best parts. By the way, while it does that and basically turns either more elemental, atomic, or molecular, right? That's an electron redox flow. That's potential. Right? Just from the very gas itself, the liquid propellant, accelerant, gas, petrol, whatever version, that'll do it too. Of course, I dope up the cylinder sidewalls. I have to do that to be able to help with that, right? Because that's kind of how that works. So, but it also is kind of the end of it. Right, like the big part was like, this thing is fucking a little bit big, bro. Like, this air filter and the intake manifold and all that, you know, it's a little big. It's a little big. Like, I'm not gonna lie, it doesn't weigh as much as them. I get it, except it actually weighs more. All depending on how you look at it. And more efficiency always comes at a cost. My cost in this instance is actually still weight and more parts, basically, that are really simple and won't break down at all very easily. They will, everything does, you know. But I solved the one issue that, like, I kind of didn't want to deal with for their design. And their design is very good. And I had a similar one myself. I talked about it back when I used to live with my parents in Chandler. So there's that. But I described it a little bit less in detail than this. And then I went further into detail, I think, later on. But there are some issues that I have with it that I just personally don't want to deal with for that. And the only way I was able to really kind of fix it is by effectively strengthening it in very specific ways for the connecting rods and the gears that, hey, I just, you know, didn't want to do it. It works. It works just fine. In fact, you really ramp up efficiency once you add in a couple of things. And it presto change again, right? You know, it's totally worth it for some people. In all ways. Yeah, like, why wouldn't I do it? And same thing for me. It's like, well, like, you know, you cost basically for this little engine. I mean, there are 250 cc, whatever it was, you know, that for what it's worth, motorcycle engines. Yeah, and this is okay. This is the big whoa. What did you just say? Moment, right? Let's say he made 10 for his 125 or whatever, right? Then he got to, let's say, objectively, he got to 15, you know, off of that, right? And, like, that was really good stuff, okay? Right, now, I'm not the same size, right off the bat. 250, that kind of thing. It's bigger, you know, of course it weighs a little more, all in, for what it's worth. And, I mean, I'm already a bigger engine, so I'm going to weigh a little more, right? So then a regular 250 might make like 200 in no way, right? Mid 20. I'm making 200. Yeah, that's why I said that. I'm making 200 fucking horsepower. This is so balanced, I can literally run this at such a mind-bogglingly stupid RPM that would break anything, basically. Because I have always a pressurized air system in one area or another that's vacuuming or, like, cushioning and more. It's always balanced. It's straight up and down. I have piston rings and then an oil ring in the center, right? There's, like, practically no big blow by. The little bottomer, same kind of thing. Piston ring, oil ring, right? Center, right? I didn't quite describe that, but that's how that would work. Yeah. Right. Cool stuff. 50,000 RPM I can hit. Because I'm effectively saving myself by having both the hydraulic fluid, which is what I ended up eventually using, because, like, screw oil, you know, I needed to be a little bit faster, a little bit less, you know, anyways. But then also, like, the air pressure both at the top and at the bottom, the accelerative forces are insane, but then it's like it's always being catched every single time at all the right times. So I was like, oh, I don't really need 200. Fucking what? And it's like, yeah. Well, so here's the thing, though. I can do more than that. I can hit pressures higher than that. I can hit temperatures much higher than that. Scary levels of that from the start. Remember that compressor? That compressor can hit this in such a way that it would basically be a bomb at the top into the tens of thousands of PSI. Because there isn't a header. But, you know, at the right RPM, let's say it was 30,000. And, like, this isn't a square cylinder. Of course, it's not technically, The stroke never goes all the way to the bottom because, of course, there's a bottomer now, right? Right. It matters so much, right, to someone, I'm guessing. But, like, right, it's technically an undersquare kind of design sort of thing, but it acts like a square as a result, which is fine. However, the only way, once you get to a certain RPM, to continue accelerating and gaining any kind of torque is detonation velocity gases, which means I have to actually mix it together under very high heat and pressure, both oxygen and the fuel. Well, it's really not a thing. Like, oh no, I'm running quite rich. I'm running stoichiometric mix practically, and I'm looking to blow it the hell up. And then I'm still pouring in gas and air together at once it's already burnt. Which is the equivalent of, oh shit! And that'd be great for some people who need that. But I'm probably not going to be one of them, and most people aren't, right? For what it's worth. Especially when it's like the bottom will just be exhaust, most likely. Most of the time, it's like... just trying to get the heat right. Trying to get the pressure. But I can maintain that pressure at that bottom. I can keep absorbing some of that heat for what it's worth. And remember the whole like exchanging undulation thing? It's less heat, but it's like it has to exchange and all that. There's thermal photovoltaic that I can get in there eventually. There's a lot there I can do. So the point really was that, oh, yeah, I can actually go way further than 200 horsepower at a 250cc. In fact, so much further that I broke any real logic to most people of like, I want a 250cc engine. And it's like, oh, so you want like 5,000 horsepower? No, I don't. What? Meanwhile, my crank is just like, it's the adamantium crank. It's almost never that, for what it's worth. It's a torque converter like crank, effectively. It's a fluidic crank. You know, that almost never-endingly goes to a fluidic transmission. It's essentially another version of a bunch of gears that go to conical and ring and ball, you know, that all like shift and then like overlap like a multi-CVT pack that I always seem to make, because it's like the only way you can get it to not break, and I mean break, into an explosion of many parts. Right? But it works with the material strengths that we can already make. With all of those things, it will work. But most people don't want 5,000 horsepower, or, for that matter, thousands of foot-pounds of torque, for that matter, either. So, as a result, I was like, I'm going to tone it down. I'm not going to do that. I'm pretty sure they'd still not want it as 1,000 horsepower. You know what I mean? So, what's actually supposed to be... Because I usually seem to settle on the same end result. 500 foot-pounds of torque almost immediately. Right? And it can go up to about 25 to 28K. That satisfies almost every person on the planet. Like, it will manage to do everything you need it to do. Even though it can easily hit in the thousands of foot-pounds of torque. But I don't want that. Because most people don't want that. You know what I mean? Same thing with even more thousands of horsepower. So it's like, most people will never want that or need that. Ever. It's like, but I want it. It's like, yeah, okay, sure. You always say that until then you have to drive it. And then you have to burn that level of fuel and all the rest. So, it, generally speaking, is almost never necessary or worth it. Right? However, you can do it. If you really needed to, you could do it. But I usually settle for 500 foot-pounds of torque very early. We're talking like less than 1,000 RPM, right? Which is great. And then up to 28K, and it'll maintain that. And I usually have it drop. Just FYI, I use like at 500. I'm intentionally neutering the engine specifically just so it doesn't become scary when you start pushing it into those higher and higher RPMs for anyone to drive. It really wouldn't matter who they are. Even like an F1 driver would be like, ugh. So that's the end of that like design idea, because it's like, oh, I can't really fucking make it better without just turning it into a literal gas, turbine, like the undulating blade thing I talk about. It's just like a bunch of heat exchanger, all that, right? That's effectively a burn in the center, and then there's air that goes through the outside, and all of that then goes to, ultimately speaking, electrical potential energy, right? And then I made my own version of an electric motor, which, by the way, effectively is using the Z and the repulse, and oscillating and all that stuff. But, of course, it rotates to be able to do that in a counter-rotating with, plates that move in and out. And more or less just so that way it would fit directly into either the intake or the exhaust of that given design, so that way I can use that as extra potential energy, and it's a flywheel-like battery to its own self, which means both for the air intake but also all that other stuff, it becomes better in terms of efficiency. And it's more compact because it can use chemical right off the bat, and it's like a fuel cell strapped to an electric motor. Like, literally, it's what I'm doing, except it's going to use vibration, it's going to have all the thing. So it's objectively outright just more efficient than any other fuel cell out there. I get more time to actually make that heat and heat exchange, continue doing the electron redox flow, and more increase of electrical potentials. So that was the end point. It's like there's no real way to make it better than that point. Like, it's like already turning all that it can for heat and all of that into straight electrical, but like so close to 100% that it gets other energy from other places and looks like it's past 100%. Right? So, and as a result, that doesn't really work. You can't get it past 100%, in that context. So, theoretically, there is a maybe there, but I'm going to move on. And so this turns into, you guessed it, it's the most efficient way of actually burning fuel, and it turned out to be a marriage of explosions and electricity. It's always a hybrid, it seems like. It's always a heat exchanger, catalytic converter, fuel cell, moving, bending, diaphragmic intake, all the things. Spinny doohickey. Hey, sure, it goes up and down and it flows. It also spins. You know what I mean? And I know, it's like a spinny doohickey, that's all we get, right? And it's like, yeah, well, I'd go over all the, multiple words that it seems to, it's a Z-pinch, repulse, electric motor, heat exchanger, fuel cell, high efficiency, fuel burning, rocket stove, compressor, jet engine, all the things, essentially. Every cycle you can imagine, except, oh, by the way, shocker, there aren't cycles like what I'm talking about. So, I'm a modified several different cycles, and so I just gave up and I went, it's the Lemke cycle. You have to deal with that. It's the Lemke cycle. There's a catalytic conversion with solenoids and all the rest, with Z-pinch and repulse in the cylinder in the very piston head. It's a Lemke cycle. You get it? You know what I mean? Like, there's a vacuum underneath, because that's basically what that would look like to it. It sucks itself up. Wouldn't you know, there's no cycle that sucks something up. That's a Lemke cycle. There's no cycle that uses, that's right, conversion of electron redox flow energy to make movement work energy for a linear accelerative solenoid. Lemke cycle. There's no, oh, by the way, it can technically always burn air and fuel together at all points. All the time. One stroke. Lemke cycle. You know what I mean? All of that. It's a Lemke cycle. It's all the things perfectly put together, making it work as best it can. Lemke cycle. Fuck all these individuals trying to do it exactly as perfect. No. I'll do it good enough. And then, no. I'm not even done yet. Watch me. I'll do it even better. Lemke cycle. Because I'm John Tyler Lemke. That's my full name. So it's like, hey, it's after my last name. It's not after the other theoretical physicist guy that also has the same last name, Lemke. By the way, added him on my Twitter one day. I think it was either Blargy Payson or my Xenon Reality about his opposed piston. And I was like, well, if you just use a ring valve and you manage to make it effectively a little bit further away, then you have intake and exhaust. So, like, you have the center as your intake and exhaust. You can use the outers, but those are two bottomers, but it's header bottomer. Anyways, point is, and next thing you know, you have 3 combustion zones. And it's more objectively efficient. I designed those ones too many damn times, for what it's worth. I got bored of them. I'm not kidding. Like, I got to a point where I was like, I made a 49cc, actually, engine, make 500 foot-pounds of torque, and it could go up to 28k. I have that already on my YouTube channel. And I was like, that was without this. That was without this design. It's like, this design makes it so I have that even more compact, with less that I need to do to make it happen. And it'll last even longer. Right? And it's like 49cc. We have to be objective here. Very pedantic, because when they pull you over, because they will, with your little dice gun, 49cc. It's definitely a motorcycle. Meanwhile, you're passing by at like 200, 250, 300 miles an hour because you've got 500 foot-pounds of torque, and you can just keep pushing to like some ridiculous RPM. So, usually kind of dangerous, especially when it will weigh less by far than any 49cc that's ever going to try and make that level of power. Or anything that even makes that level of power, that's a bigger engine. So, that usually is a good thing, but also not such a good thing. You see what I mean? Like, I'm making dangerous engines now. Right? Like, it's all possible. Oh, absolutely. Even without all the extra electrical recapture, it just means more fuel. More pressure, more fuel, all of that. Right? But it's like, hey, what if I didn't want to make like actually stupid dangerous levels of but they're all like that after a point, for what it's worth, so I'm gonna move off of that. But okay, what if I didn't? Well, now I can make it a lot easier. Now I can absorb the vast majority of the heat. Now it's just giving it the right amount of time and the right amount of continuation of effectively like a one stroke that I kind of bleed out the exhaust just enough to keep it going. Where it's like, and then it's like, yeah, but I didn't get all of it. It's like, it doesn't matter. I know it sounds like it does, but these sides right here, the outsides, way higher pressure. And because this is lower pressure, it's going to compress it. And it's like, and no, it doesn't seem like it'll be, but it's like the moment it does this, it's back to business. And I'm about to like do that, lower the pressure over here, but also add more pressure in the center. Yanks it apart, right? But like that saves it from being anything that will die. Meanwhile, it's always getting cooled, and it's always making more electrical potential, always making more. Right? Meanwhile, that's the part that I enjoy about opposed pistons. Opposed pistons are easy all day to make like that. Okay? Right? Like, and just have them go from an outside back towards a center point. Yeah, those are the two counter-rotating things. Those are some arms, right? But it's like, Yeah, but I don't really like doing that most of the time. You know what I mean? Like, I don't want it to be a little bit better. So that's kind of one of the gear things I talked about. I eventually went to like